Hello, Assalamualaikum. My name is Ahya-Elhafiz bin Ahya-Elmuddin. So today I'm going to present to you about my final year project titled Numerical Analysis on Exhaust Airflow through Stationary Solid Desiccant using CFD. Okay, as an introduction, the project used mixed mode dryer combined solar radiation with preheated air in the solar collector. And it used desiccant to enhance the performance of solar dryer, and the most common desiccant used is silica gel. The analysis runs using software ANSYS Fluent R1, and it is used to investigate the airflow behavior. And the study is the study of 15% and 35% of total mass airflow inside the desiccant, which is 149 kilogram per hour. Okay, so the problem statement is that previous mixed mode type of solar dryer release exhaust air at the atmosphere. So silica gel desiccant is used in this project to absorb and reuse the waste exhaust gas, because the exhaust gas is high in humidity and the desiccant is used to absorb the moisture from the air. And it is also can increase the solar dryer efficiency, and the desiccant bed is used to overcome the problem. Okay, the research objective is that to investigate the airflow behavior as it pass through the solid desiccant, and also to determine the suitable percentage of exhaust air to be recirculated. The percentage of exhaust air is around 15% and 35%. Okay, the scope research is the research the project use solar dryer, a mixed mode solar dryer, and the stationary solid desiccant is used, and the absorbent material is silica gel. The overall dimension for the solid desiccant bed is 800 millimeter times 252 in width millimeter and 254 millimeter in height. There are 14 silica plate that is used in the desiccant, which in inverse V shape. So the other than that, the percentage of recirculated air used are 15% and 35%. And the airflow behavior is observed by using ANSYS software. And then we continue for process flow chart. It starts with desiccant design and dimension, determining the desiccant design and dimension. After that, we go to parameter selection, and then after that, we go to material selection and properties of air and silica, because the silica need to have porosity properties. And then we go to pre-processing, which this will start the simulation, and the iteration, the cycle is set to 1000 times. And then report writing, and if everything goes well, and the final project is done. Okay, now we go to research design. The research use a portion of 15% and 35% of exhaust air is recirculated and flowed to the system. Exhaust air is in high humidity. So the silica gel is placed inside the desiccant here in the middle to absorb the moisture from the exhaust air. So this is the exhaust. And air will be sucked in through a pump and double pass, which is here, to accelerate the heating process of air. And the area is where desiccant is placed and the exhaust air is recirculated will be calculated. Okay, this is the solar dryer. The overall dimension of the solar dryer is 2254.5 millimeter, 1966.25 millimeter, and 3239.11 millimeter in height. So this is a mixed mode desiccant solar air dryer use the principle of heatless regeneration. The solar dryer use desiccant to help fasten the drying process while increase efficiency because the air is not waste. It the air didn't waste to atmosphere, but it is recirculated back into the system, and a portion of 15% and 35% of the exhaust air is recirculated back. This is the solid desiccant. The overall dimension for the desiccant bed is as below, as above, and the ambient air will travel through the inlet here, then pass through the dry desiccant, which is stored inside the desiccant bed, which are the silica plate. And the simulation will be run using ANSYS Fluent R1, the flow analysis to study the airflow behavior inside solid desiccant, and the test run, it will have two test run, which is one for 15% and another one for 30%. And the parameter is also known as limitation or variable for the project, and parameter and variable are closely related. So the capacity is 10 kilogram, and if the initial moisture content is 87%, the final moisture content is 7%, the solar radiation is 600, and ambient temperature is 30 degrees Celsius, drying temperature is 70 degrees Celsius, the maximum drying temperature is 70 degrees Celsius, and ambient relative humidity is 50%, and the mass airflow is 149 meters. Okay, observation method. So the analysis starts with design and geometry of the desiccant. So this is the step for the analysis. So we start on determining the geometry, and after we settle in geometry, we go to meshing. In geometry, we need to determine the volume of the whole desiccant. And then we proceed to mesh the meshing process. We need to mesh the volume to ensure it is properly set up for analysis. And then we go to setup for analysis. Then the solution of the analysis will be determined. So the porosity, the inlet, the velocity, and the pressure all is determined in the solution. And lastly, the results came out in the sixth step. Okay, this is the design. Okay, this is the design of the desiccant, the geometry, and this is when we do stitching to stitch all the surface to become a solid combined. And then this is the total volume of the air inside the desiccant. Okay, in meshing, so the details of meshing is we use solver preference is proven, element order is linear, and the element size is 5 mm. So each element is standard to 5 mm, and the orthogonal quality is as well. Okay, now we go to velocity contour analysis. Okay, contour is a way to show a three-dimensional surface on a two-dimensional surface. So this is used to make more understanding about how the air flows inside the desiccant. So the contour run for both tests. In order to see the comparison with both tests, we can see that the mass flow rate is low, and when the mass flow rate is low, and the flow through silica plate is also very slow. So the inlet, in the inlet, the air travels faster, and when it reach the desiccant, the silica plate, the velocity go down, decreases. The humid air was absorbed by the silica plate, while passing through it inside the bag. Okay, now we go to velocity streamline analysis. So streamline analysis is where we can see the flow of the uh, air inside the desiccant. So streamline is a line that is perpendicular to its direction of instantaneous velocity. The streamline is almost identical for both tests. This is because the design of the desiccant is same. So the velocity doesn't bring a big effect on the airflow. So the maximum velocity for 50% mass airflow is 100 and 1.143 meter per second, and the mass airflow for 35% is 3.141 meter per second. This shows that the airflow in the system is stable in low and high velocity. Okay, this is the graph of velocity and pressure. So on the left is the graph of velocity, and the right side is the graph of pressure. In velocity, we can see that when the air enters the desiccant, it immediately uh, trend down, until from the start until the end. And same goes to the pressure also. So the pressure is about 1.11140, and the highest pressure is 1.140 Pascal, and the highest velocity is about 0.95 meter per second. Okay, CFD analysis. The analysis is based on the percentage of total mass flow rate of air that needed to be recirculated inside the system through the desiccant. From the simulation, the result from both percentage of mass airflow is almost the same. The first test run uses 15% of 149 kg per hour mass airflow, and the second test run uses 35% of 149 kg per hour. There are slight changes in the first analysis. So 35% percentage of air achieve a higher velocity and pressure, hence can increase the overall efficiency of the solar dryer in the velocity streamline. Okay, as a conclusion, the project aims to analyze the solar dryer exhaust air effect on regenerative desiccant. It is based on the percentage of total mass flow rate of air that needed to be recirculated inside the system through desiccant, which is 50% and 35%. The desiccant material are silica gel, and it is used to absorb moisture as the air flow through it. Investigation It is to investigate the airflow behavior as it pass through the solid desiccant by varying the percentage of air recirculated. So this is the main thing that investigate in in this project. And the total mass airflow is 149 kilogram per hour. And as we can see, 35% percentage achieve a higher velocity and pressure, hence can increase the overall efficiency of it. So simulation can be improved for more precise data collection by increase the number of iteration. So my iteration is around 1000 cycle, and if uh, the data need to be more precise, then uh, you can do more iteration cycle, and include study of a desiccant behavior and desiccant lifetime. Research on parameter setup to achieve more sensible data, conducting experimental work, and would then confirming simulation conclusion against experimental data are both required. Experiment with different desiccant designed to find the best setting for increasing efficiency. And lastly, the project potential. Malaysia is a country that receives high amount of sunlight, and the temperature in Malaysia is almost constant throughout the year. So the effectiveness of solar dryer can be fully utilized in few of the amount of sunlight received and the temperature. Projects should focus more on seafood industry where local fishermen often dry their food and sell to the market. By introducing solar dryer to the dried seafood market can boost up the practicality of solar dryer with quality and cleanliness. Implementing two desiccant tower, which one will go under drying process, another one will regenerate the desiccant by removing the moisture, will be uh, a good exposure for this project. So that's all for me. Thank you very much. My name is Ahya-Elhafiz. Thank you for your consideration and thank you for your attention. Selamat.